Now this time with our compound event, we have more than one decision when we've got more than one outcome that's favourable. So from our example there before, if we want a head and an even or a tail and an odd, then we have more than one possible outcome there. So that's what we're looking at with our compound here. So H and an even or a tail and an odd. So if we have a look here, we have head and an even. Well, there's that 1, 2, 3. Tail and an odd. 4, 5, 6. So there's 3 there out of 6, and 3 out of 12 there, 3 out of 12 there, which gives us 6 out of 12 altogether, or a half. So the idea, if you look here what we did, head and an even, well, there's 3 favourable events out of 12 there, and tail and odd, there was 3 there. The or, we've put an add in there, and put an addition in there. So what we're getting in that idea is that where we see the word or, that means to add our probability. So again, a lot of times this one's not implicit. This one's stated there because you need something to occur or something else to occur. So basically we're looking at more than one favourable event to occur there. But the idea remains the same. Or if we see that, we need to add our probabilities. So Sarah throws 2 dice. Find the probability of getting a pair of 3s. Well, that's a 3 and a 3. 1, 6, 1, 6. Any pair. So there's a number of ways of looking at this one. The one I want to look at here is basically on the first dice, it doesn't matter what you get on the first dice because all you need is the same. So the idea of get any of the numbers is 1. Doesn't matter, you can get any number you like, and gives us a multiplication, and then we want the same. So you've only got 1/6 of a chance to get the same as what you had on the die the first time. So it gives us 1/6. A total of 9. Now, to get a total of 9 on 2 dice, we need a 3 and a 6, or a 6 and a 3, or a 4 and a 5, or a 5 and a 4. They're the only ones that give you a 9. So get a 3 and then a 6 is 1 in 36 chance. It's like up here. There's only one way you can get 3 and a 6. There's only one way you can get 6 and a 3, 4 and a 5, 5 and a 4. Add the 4 of them together, it gives us 4 on 36, or 1/9. So you see the idea of the or situation occurring there. So probably of getting a 9 or a 10 or an 11 or 12. So notice the or gives us the addition there between them. We just worked out there was 4 in 36 chances of getting a 9. For 10, there's only 3 in 36 ways of getting it because it's 2 5s or a 6 and a 4 or a 4 and a 6. 11 is either a 5 or a 6 or a 6 or a 5. And a 12, well, there's only one way to get a 12, and that's with 2 6s. Gives us 10 on 36 or 5 on 18. This time we've got Dino and Chris using a spinner, and they're playing a game. They take it in terms, and the player with the highest score won the game. So probably that Dino scored a 6 in a game. So that occurs when Dino gets a 2 and a 4, or a 4 and a 2, or a 3 and a 3, which basically a quarter of a chance each time. So quarter times a quarter, quarter times a quarter, quarter times a quarter. So there's three lots of that. That's where we get the 3 times a quarter times a quarter. And again, same thing. Dino scores 6. What's the probability that Chris won the game? Well, Chris needs a 3 and a 4, or a 4 and a 3, or a 4 and a 4, which means he can do the same thing. There's 3 lots of the 1 quarter times 1 quarter to get that score of greater than 6. This time we've got a plant that can grow to 4 meters, and the probability of that is 1/3. If you plant 2 of the plants, what's the probability that you get 1? Okay, so it means you get 1 plant grows or it doesn't grow. So 1/3 of a chance that it does grow, 2/3 of a chance it doesn't grow. And it just says probability that only one of them. So it doesn't matter whether it's the first or the second. So see how we get the or, the probability that doesn't, and then probability that does. Totals 4/9. Or the probability that both of them, well, we want a T and a T, the plant grows to the height, or it doesn't, times itself there, gives us the 1/9. Now this time we've got situation where we have what we call non-mutually exclusive events. So events can be either mutually exclusive when we deal with compound events, or non-mutually exclusive. And we can see the difference here. So probably of rolling a 6 on a die is 1/6. Probably of getting an odd is 1/2. Probably of getting less than 3 is 1/3, because it's only a 1 or a 2. Now the probability that you've got an odd or some number less than 3. So there's our compound event there. So we've got an addition. But what we've got to be careful about is that you have favourable events in the odds, which are also favourable events in the less than 3. So because 1 is both less than 3 and odd. So what we've done is we've doubled up our counting there. So if we just left it as a half plus a third, that wouldn't be right, because we're counting 1 twice. So that's why we've subtracted 1/6 there. So it depends on how you want to do problems like this. If you just want to look at it and go, well, I can't count the 1 twice, so I'm not going to. So the probability of less than 3 would be 1/6 at that point. Or you do it like this. Do your probability of one event plus the probability of the other event occurring, and subtract the number of event elements that are common to both. And that's what that one's doing there to give us, and that will give us the correct probability. So we've just got to be careful when you have what we call non-mutually exclusive events. So the two, like we had the heads and the head and an odd, head and even, and tail and an odd earlier. But both those were mutually exclusive, because there was no elements in both those sets that were the same. So we've got to be careful to make sure we can identify whether our events are mutually exclusive or non-mutually exclusive.